All right, welcome to the review for Unit 10, Polynomials. All right, so we learned some vocabulary in the first lesson. All right, so the type of polynomial here, because it has three terms, the terms are separated by adding and subtracting, is called a trinomial. And this trinomial has a 2 for an exponent in that term, a 1 in that one, and a 0 in that one. You pick the highest the number in the highest term. So the highest exponent is 2, so this is a second degree trinomial. All right, so this has two terms separated by addition, so this is a binomial, and there's a 1 there and 1 there, so this is a first, it doesn't matter x or y, first degree binomial, because the highest exponent is 1. Now this is a monomial, right? There's no adding or subtracting in a monomial. And this is where you add them together, and this is a sixth degree monomial. Right? And we learned these various patterns. When you add x plus 7 plus x plus 7, you add to the like terms, x plus x to x, and 7, you get 14. When you subtract these, you subtract the like terms, and x plus 7 minus x plus 7, no matter what value x is, will equal 0. And x plus 7 times x plus 7, right, equals x squared plus 14x plus 49. That's where we learned FOIL. All right, so rewrite this in descending order of the exponents of x and name the degree. All right, so the highest exponent of x is 2. So we go negative 9x squared plus 8xy squared. Neither of these have x, but we put the plain old number at the end. Now, that's the correct order in descending order of exponents of x. But then for the degree, you look at this 2, you add 1 plus 2 together and get 3. That one is a 1, and this one is technically a 0. So this is a third degree polynomial, right? There's 4 terms, so we're just going to call it a polynomial. And that's now in the correct order. Negative 9x squared plus 8xy squared plus 4y plus 1. Next. All right, so that's not in the right order, right? X to the fourth has to go first. X cubed goes second. Negative 7x cubed y squared minus 9xy, then minus 8. That's the correct order. There's a 4 here and a 3 plus 2, which makes 5 there. A 1 plus 1 there makes 2, and then there's a 0. So the highest degree, right? You don't add them all up. You just add them up within each term, and then you pick the highest. So this is 5th degree, and this is a 5th degree polynomial. 4 terms. Okay, then we learned to add them, right? And you're adding like terms. You truthfully already know how to add like terms. 3x squared plus negative 2x squared, x squared. Don't write 1x squared, x squared. 8xy minus 8xy, that's 0, right? So I don't have to write 0. All right, those are done, those are done. Negative 4y, all right, plus 7. That's the answer, right? Because there are no more like terms. We combined our like terms. All right, so now we're subtracting. So what I like to do is I rewrite the first one, and then I distribute a negative 1 here. Right, so negative 5x cubed plus 6xy squared minus 9. Now I combine my like terms, x cubed minus 5x cubed, negative 4x cubed. Negative 8xy squared plus 6xy squared is negative 2xy squared. Right, I've done all that, and 6 minus 9, negative 3. And notice if I write them in descending order of x and I do them in that way, then the answer is in descending order of the exponent of x. So subtraction, you just distribute a negative 1. Now, this is subtraction in the vertical format. All right. Now, you can rewrite it in the horizontal format like you just saw and do it that way. Just because it's given to you in the vertical format doesn't mean you have to do it in the vertical format, but I will. Negative 6x squared minus 2x squared is negative 8x squared. 2xy minus 3xy is minus xy. 2 minus 3 is negative 1. Nothing minus 8y is negative 8y. Negative 12 minus nothing is negative 12. All right, now did you get these signs right? Because the vertical method with addition is no harder than the horizontal method. But the vertical method with subtraction, you have to be careful. That's why you should write this minus nice and big. But that is the answer, okay? And there are no like terms because x, y's, and y's are not the same thing. You have to have the exact same letters with the exact same exponents. All right, so now we also did scientific notation. Now, scientific notation, right, these are not like terms. If you have 8.4 y to the fourth plus 7 y cubed, you cannot add those together. And that's what we've got here, just with 10 where y is. So what we learned is we have to make them, you could force it, and we have learned how to do that now. You could force it and manipulate them so they both have the same exponent by moving the decimal point around. But I found too many mistakes doing it that way, so I'm just going to make them regular numbers. 1, 2, 3, 4. That means I have 3 zeros, which means I'm adding 84,000. There's 7 has its decimal point there. I move it 3 times. That's 7,000. And I add those together and I get 91,000, which it says you have to write the answer in scientific notation. So it's 9.1 times 10 to the fourth, right? 1, 2, 3, 4, right? And scientific notation always starts with 1 through 9, right? You can't start with 10. It can't start with 0.9, all right? It has to start with 9, 1 through 9. All right, here's subtraction. Same idea. These are not like terms. So I'm going to make them regular numbers. So I'm going to move this twice, 1, 2. That's 0.0206. And I'm going to subtract, move this 3 times, 1, 2, 3, 2 zeros, 0.0017. I'm going to subtract these. I have a little borrowing to do here, 2, or regrouping. That 2 becomes a 1, that becomes a 10, cross it out, becomes a 9, that becomes a 16. 16 minus 7, 9. 9 minus 1, 8, 1, 0, and you get 0.0189. But the answer has to be in scientific notation. So it must start with 1, right? 1 through 9. 1.89 times 10. How many times did I move the decimal point to get it behind the 1? Twice, but this is a small number, right? That's 189 ten thousandths. That's 189 out of 10,000. That is a small number. And that is written 1.89 times 10 to the negative second. Now that's not a polynomial, but it follows. We're using the same rules, right? You have to add like terms. Since there aren't like terms, we're making them regular numbers. That's why we also multiplied in scientific notation here. Okay, so we have distributive property here, right? That's a monomial times a polynomial. 8x times x squared, 8x cubed, 8x times 7x, negative 56x squared, 8x times xy, 8x squared y, 8x times negative y squared, negative 8xy squared. And there are no like terms there. There is nothing with the exact same letters and exact same exponents. Right? This is a binomial times a trinomial. You have to multiply all of these by x. So you get x cubed plus 6x squared minus 3x. Then you have to multiply all of these times negative 4. And you get minus 4x squared minus 24x plus 12. And there you have like terms. X cubed, 6x squared minus 4x squared plus 2x squared minus 3x minus 24x minus 27x plus 12. All right, then we learned the FOIL method. First, outer, inner, last. 5x times x, 5x squared. Outer, plus 20x. Inner, negative 6x. Last, negative 24. You cannot leave it that way, just like you always simplify a fraction. You always combine your like terms, 20x minus 6x, 14x. And notice you get, most of the time, you get a trinomial answer. So we get x times 8x, 8x squared. Outer, negative 2x. Inner, negative 56x. Last, plus 14. 8x squared minus 58x plus 14. Right, you can multiply these in any order you want. Right, 3x plus 15 Then you multiply that times x plus 2, 3x squared plus 6x plus 15x, I'm doing FOIL, plus 30 equals 3x squared plus 21x plus 30. This is backwards intentionally, so 35 plus 7x minus 10x minus 2x squared for the last. 35 minus 3x minus 2x squared. That is not in descending order of the exponents of x, so let's turn it around. Plus 35, right? Because it was 35, and that is the answer. All right, so just like 7 squared is 49, 49 is a perfect square trinomial, perfect square, this answer is going to be a perfect square trinomial. And so we're going to get x squared plus 13x plus 13x. Well, 13 times 13, you should know from Pythagorean theorem, is 169. So it's x squared plus 26x plus 169. And if you put a number in there, let's just put 1 in there and show you this. 1 squared plus 26 times 1 plus 169, right? 1 plus 26 is 27, and 27 plus 169, right, is 16. 196. Is 196 a perfect square? Yeah, it's 17 squared, right? And I can put 2 in there. If I put 2 in there, I'll get another perfect square. Let's just prove it to you. 2 squared is 4. 26 times 2 is 52. So 52 plus 4 is 56. 169 plus 56. 225, right? That is a perfect square, right? It's not as obvious a perfect square, right? That's 15 squared, right? No matter what number I make x, I'm going to get a perfect square. Okay, so same thing here. No matter what number I make x, the answer will be a perfect square because I'm multiplying the same thing twice. 4x minus 9 times 4x minus 9 is 16x squared minus 36x for the outer, minus 36x for the inner, plus 81, 16x squared minus 72x, 36 plus 36 is 72, plus 81. This answer is not a perfect square. What happens here is 64x squared plus 8x minus 8x, that means 0 minus 1, and the answer is 64x squared minus 1. And this one, which we've done many times, x to the 4th minus 2x squared y squared, no, not minus 2, I'm thinking about the answer, minus x squared y squared minus x squared y squared plus y to the 4th equals x to the 4th. There's the minus 2x. Whoops, going too slow, too fast. I mean, minus 2x squared y squared plus y to the 4th. That also is a perfect square trinomial, right? Because I multiplied the same thing twice, just like 9 times 9 is 81, and 81 is a perfect square, so is that. Okay, let's practice for the test. All right, so this is 5th degree binomial, right? 2 terms. So we're adding, so we got 7x cubed, 0 plus negative 4x squared, negative 4x squared, negative 7xy plus negative xy, negative 8xy, negative 5 plus 5 is 0, so that's the answer. We're going to get another perfect square here. And you're going to get 9x squared minus 18xy minus 18xy plus 36y squared. And we're going to get 9x squared minus 18 plus 18 is 36. So it's 36xy plus 36y squared. Okay. Here I would write this out. This is 4 times x minus 1 times x minus 1. 4 times x minus 1, 4x minus 4. Then multiply that times x minus 1. You get 4x squared minus 4x plus 4. 4x squared minus 8x plus 4. And if you multiply it correctly in other orders, let's just show that. You could have done this x minus 1 times x minus 1 first. You you would have gotten 4 times x squared minus 1x. I'm doing the addition of the like terms in my head, plus 1. All right, notice if I multiply all that by 4, I get the same answer. But you cannot distribute this 4. You have to distribute that 4 to one term only, one other group only, let's say properly. All right, so we're finding the difference here in 2 grains of rice. So we're subtracting, and they're like terms. So there are 2 ways to do it. Since they're like terms, you could do it that way. I'm going to do it both ways. My preferred way is to just make them regular numbers. Move that twice, 0.0182. Then move this twice, 0.013. Subtract those 2. Make that into scientific notation, because it said I had to, 5.2 times 10, 1, 2, 3 times 10 to the negative 3rd grams, right? But there is another way. Since they're like terms, right? Since they're like terms, you can actually just subtract them right the way they are, line up your decimal points a little better than I did, and you're going to get 0.52 times 10 to the negative 2nd. The problem with the shortcut is, if that was the answer, that'd be great, but it's not. Right, because you have to move the decimal behind the 5, and since I made this bigger, I have to make this one smaller. All right, but you can add or subtract things that have the exact same exponent, because they're like terms. All right, area of a square, right? Sides of a square are all the same, so you'd multiply. This is this squared. And the answer is going to be a perfect square trinomial. We're going to get 25x squared plus 35xy plus 35xy plus 49y squared. You have to combine your like terms. 25x squared plus 70xy plus 49y squared. Good luck on the test.